Hello everyone, I am Balaji Rao. Welcome to BR Max class. In last class, we learned 15 formulas related to dot product of vectors. In case if you not learned those 15 formulas, that video link I'll give in cards here. In this class, we are going to do exercise number 10.3 solutions from vector algebra chapter. In this class, we will do from question number 1 to question number 6. Before going to start this video, please drop a like for this video. Without much delay, let's begin the class. You observe the first question. What they are asking in this question? Find the angle between two vectors A bar and B bar. For that, what information they given? With the magnitudes √3 and 2 respectively. Respectively means the first vector A bar magnitude is √3, second vector B bar magnitude is 2. And they given that A bar dot B bar is √6. What they are asking? Angle between the vectors. In dot product of vectors, to find angle between the vectors, we have only one formula. What is that? Cos theta. Cos theta equal to A bar dot B bar divided by magnitude of A bar into magnitude of B bar. I'll use that formula to calculate angle between the vectors A bar and B bar. First, I'll write the given information from the question. You observe the given data. What they given? A bar B bar with magnitudes √3 and 2. That means magnitude of A bar is √3, magnitude of B bar is 2. And they given that A bar dot B bar is √6. Then we need to find angle between the vectors. To find angle between the vectors in dot product, we have only one formula. What is that? You learned this formula from 15 formulas. What is the formula for cos theta? The formula is A bar dot B bar divided by magnitude of A bar into magnitude of B bar. This is the formula to calculate angle between two vectors. Now, this information I'll substitute in this formula. Okay. What is A bar dot B bar? They given A bar dot B bar as √6 divided by magnitude of A bar is √3. √3 into magnitude of B bar is 2. Okay. Now, I need to simplify this. You observe here √6 divided by √3. You know this formula, √a divided by √b can be written as root over a by b. √6 divided by √3 is root over 6 by 3. 6 by 3 value is 2 na? So √6 divided by √3 value will become √2. That √2 I written and this 2 as usual. I'll simplify this little bit. What I'll do, numerator denominator you multiply with √2. Then let's see what you will get. Multiply numerator denominator with √2. See here √2 into √2 is 2. This will get cancelled. What is remaining? You got 1 by √2. What is this 1 by √2? We got that cos theta is 1 by √2. We know in this formula theta is angle between the vectors. From trigonometry, we learned this. When cos theta is 1 by √2, what is theta value? Theta value is pi by 4. So, I calculated angle between the vectors A bar comma B bar. So, what is the angle between the vectors A bar comma B bar is pi by 4. It means 45 degrees. I hope you understand this. Now, we will move to next question. This is question number 2. Find the angle between two vectors. This is also angle between two vectors. In dot product of vectors, to calculate angle between the vectors, we have only one formula. What is that? To calculate angle between the vectors, this is the formula we have. Cos theta is A bar dot B bar divided by magnitude of A bar into magnitude of B bar. So here, they given two vectors now. First, I'll consider those vectors as A bar, B bar respectively like this. To calculate angle between the given vectors, I take in first vector as A bar, second vector as B bar. Now, to use this formula, I need A bar dot B bar, I need magnitude of A bar, magnitude of B bar. So first I'll calculate these values. From this vector A bar, you can calculate magnitude of A bar. What is magnitude of A bar? Root over. What are the scalar components of this vector? Here 1 is there. 1 whole square is 1 plus here minus 2 is there. Minus 2 whole square is 4 plus 3 whole square is 9. So what you will get? This is √14. So magnitude of A bar I got √14. Similarly, I will calculate magnitude of B bar. Okay, magnitude of B bar. How to calculate magnitude of B bar? Root over. Okay, 3 is there na, 3 square is 9 plus minus 2 whole square, that is 4, plus 1 whole square is 1. 9 plus 1 is 10, that is root 14. So magnitude of B bar, I got root 14. I calculated magnitude of A bar, I calculated magnitude of B bar. Now I need A bar dot B bar. I'll calculate A bar dot B bar. You learned 15 formulas na? In those 15 formulas, when A bar B bar given, then to calculate A bar dot B bar, we have a formula. That formula is A1 B1 plus A2 B2 plus A3 B3. Here, what is A1 B1? See here, 1 into 3. Okay, A1 B1 over plus A2 B2. Here minus 2 is there. Minus 2 into minus 2. Okay, plus A3 B3. 3 into 1. A1 B1 plus A2 B2 plus A3 B3. Okay. Now you simplify this, what you will get? This is 3, this is 4 plus 3. This what you are getting? You are getting 10. So A bar dot B bar, you got it as 10. Now you know magnitude of A bar, you know magnitude of B bar, you know A bar dot B bar. Substitute these values in this formula. Okay, A bar dot B bar, what we got? We got it as 10 divided by magnitude of A bar is what? Magnitude of A bar is root 14 into magnitude of B bar is what? Magnitude of B bar is root 14. That equal to 10 divided by root 14 into root 14. Root 14 into root 14 is 14. Now 2 table in this 5 times, 2 table in this 7 times. What you got? You got cos theta. Actually, what is theta here? Theta is angle between the vectors. We want theta. You can write theta as theta equal to cos inverse of 5 divided by 7. So I calculated angle between given vectors. I hope you understand this solution. Now we will move to next question. Question number 3. You observe this question number 3. What they are asking? Find the projection of the vector I cap minus j cap on the vector I cap plus j cap. We need to find projection of a vector on the another vector. You know the formula to calculate projection of A bar on B bar. To calculate projection of this vector on the other vector, first I'll take given vectors as A bar and B bar. You observe, I taken given vectors as A bar, B bar. What I need to calculate now? Projection of A bar, because I consider this vector as A bar. Projection of A bar on B bar. You learned 15 formulas in dot product na? In that, this formula you learned. Projection of A bar on B bar. What is the formula? Projection of A bar on B bar formula is A bar dot B bar divided by magnitude of B bar. To calculate projection of A bar on B bar, I need A bar dot B bar and I need magnitude of B bar. So first I'll calculate A bar dot B bar as well as magnitude of B bar. First I'll calculate A bar dot B bar. What is the formula you know to calculate A bar dot B bar? The formula is A1 B1 plus A2 B2 plus A3 B3. A1 B1, that is 1 into 1 plus A2 B2, that is minus 1 into 1 plus A3 B3. Here K bar components are not given na? You can write 0 into 0, that is 0. Okay, if I simplify this, what you will get? This is plus 1. This is minus 1. 1 minus 1 is what? 0. So when I calculate dot product of these two vectors, I am getting 0. To calculate projection of A bar on B bar, I need magnitude of B bar. Na? That also I will calculate. Magnitude of B bar. How to calculate magnitude of B bar? Root over. This is B bar. Na? Here 1 is there. 1 square, that is 1 only, plus 1 is there. 1 square, that is 1. That equal to root 2. So I'll substitute A bar dot B bar and magnitude of B bar values in this formula. What is A bar dot B bar? A bar dot B bar is 0. Divided by magnitude of B bar is root 2. 0 divided by root 2 is what? 0. So you got that projection of A bar on B bar is 0. Projection of this vector on the other vector is 0. I hope you understand this. You observe this question number 4. This is similar to last question. Projection of this vector on the another vector. To calculate projection of this vector on the another vector, first I'll take this vector as A bar and the another vector as B bar. I consider given vectors as A bar and B bar. You know the formula for projection of A bar on B bar. What is that formula? Projection of A bar on B bar formula is A bar dot B bar divided by magnitude of B bar. So to calculate projection of this vector A bar on the another vector, I need to calculate A bar dot B bar as well as magnitude of B bar. Okay. First, I'll calculate A bar dot B bar. What is the formula to calculate A bar dot B bar? The formula is A1 B1 plus A2 B2 plus A3 B3. So here A1 B1, 1 into 7, A1 B1 plus A2 B2, 3 into minus 1 plus A3 B3, 7 into 8. 1 into 7, 7 minus 3 into minus 1, that is minus 3 plus 7 into 8. 7 into 8 is 56. If I simplify this, 7 minus 3 is 4. 4 plus 56 is 60. So I got A bar dot B bar as 60. Now I'll calculate magnitude of B bar. Okay, magnitude of B bar. Magnitude of B bar equal to root over. This is the vector B bar. Here 7 is there. 7 square is what? 49. Plus minus 1 is there, minus 1 whole square is plus 1, here 8 is there, 8 square is 64. If I simplify this, 49 plus 1 is 50, 50 plus 64 is 114, root over 114. Now I got A bar dot B bar value, I got magnitude of B bar value also. I'll substitute these values in this formula. Okay, what is A bar dot B bar? A bar dot B bar is 60 divided by magnitude of B bar is root over 114. You can stop this problem here. If you want, you can simplify a little bit. So I calculated projection of A bar on B bar. What is the answer? 60 divided by square root of 114. I hope you are understanding these problems. These are very easy problems. Only the key thing is whatever the 15 formulas we learned related to dot product of vectors, you need to be thorough in all those formulas. Then you can do these problems very easily. Okay. Now we will move to next question, that is question number 5. You observe this question number 5. This is a little lengthy question, but it is easy question only. What they are asking? Show that each of the given 3 vectors is a unit vector. See here, first vector, second vector, third vector. Total 3 vectors they given. They are asking you to show that each of them is a unit vector. How to show a vector is unit vector? Very simple. We will calculate its magnitude. If its magnitude is 1, we can say that it is a unit vector. So first what I'll do, I'll calculate magnitudes of all 3 vectors. If all 3 vectors magnitude is 1, I can say that they all are unit vectors. After that, they are asking also show that they are mutually perpendicular. That also I'll do. First, I'll prove that each of the given vectors are unit vectors. You see, I consider first vector. Now I am calculating its magnitude. This is scalar, this is vector. You know this formula. Magnitude of m a bar is m times of magnitude of a bar when m is positive. Here 1 by 7 is positive only. Na? How it looks? It looks like magnitude of m a bar. Magnitude of m a bar is what? M times of magnitude of a bar. So what this will be? This will be 1 by 7 into magnitude of this vector. Okay, what is magnitude of this vector? Magnitude of this vector is root over, yes, 2 square. 2 square is 4 plus 3 square. 3 square is 9 plus 6 square. 6 square is 36. That equal to 36 plus 4 is 40, 40 plus 9 is 49, root 49 is 7. So what happened? This 7 will get cancelled. You got 1. That means you got that magnitude of this vector is 1. From this what I can say? I can say that this is a unit vector. Similarly, I will calculate the magnitudes of this vector as well as this vector also. You observe the second vector. I consider second vector. Now I am calculating its magnitude. How it looks? It looks like magnitude of m a bar. What is magnitude of m a bar? M into magnitude of a bar. So what you will get here? 1 by 7 into magnitude of this vector. What is, how you will calculate magnitude of this vector? That is root over. See here 3 is there, na? 3 square is 9 plus minus 6 whole square is 36 plus 2 whole square, that is 4. So that is 1 by 7 into 36 plus 4 is 40, 40 plus 9 is 49, root 49 is 7. So these two will get cancelled, you got 1. That means when I calculate magnitude of this vector, I got 1. From this I can say that this vector is a unit vector. As they are asking to prove each of the given vectors are unit vectors, I'll take the third one, I'll calculate its magnitude. Calculating magnitude of third vector. This is also of the form magnitude of m a bar. What is the formula? M into magnitude of a bar. So what you will get here? 1 by 7 into magnitude of this vector. How to calculate magnitude of this vector? Root over, yes, 6 square, that is 36 plus 2 square, that is 4 plus minus 3 whole square. Minus 3 whole square is 9. Okay, 36 plus 4 is 40. 40 plus 9 is 49. Root 49 is what? Root 49 is 7. So this 7 will get cancelled. You will get 1. So they given 3 vectors. I calculated their magnitudes. I got their magnitudes as 1. So from this what I can say? I can say that given vectors are unit vectors. Therefore, given vectors are unit vectors. So first part of this question is completed. What they are asking, also show that they are mutually perpendicular. That means this vector is perpendicular to this vector is perpendicular to this vector, and this vector is perpendicular to this vector. I need to show that they are mutually perpendicular. First, I'll prove that these two vectors are perpendicular. Next, I'll prove that these two vectors are perpendicular. Next, I'll prove that third vector, first vector are perpendicular. So that I'll conclude that they are mutually perpendicular. In dot product theory part, what formula you learned? To prove two vectors are perpendicular, the formula is we will prove that their dot product is 0. Always remember, whenever you want to prove two vectors are perpendicular, we will prove that their dot product is 0. First, I'll consider first vector, second vector dot product. You observe, I consider dot product of first vector as well as second vector. You know this formula in theory part of dot product of vectors. You learn this formula m a bar dot n b bar. Here m n are scalar. M a bar dot n b bar can be written as mn times of a bar dot b bar. So here m is 1 by 7, n is 1 by 7. So this can be written as mn into dot product of these two vectors. Mn, that is 1 by 7 into 1 by 7. 1 by 7 into 1 by 7 is what? That is 1 by 49 into dot product of these two vectors. Okay, dot product of these two vectors. How to calculate dot product of these two vectors? You know the formula. A1 b1 plus a2 b2 plus a3 b3. Okay, 2 into 3. 2 into 3 plus 3 into minus 6 plus 6 into 2. Okay, that equal to 1 by 49 into 2 3s are 6 minus 18 plus 12. Okay, so that equal to 1 by 49 into 6 plus 12 is 18. 18 minus 18 is 0. 1 by 49 into 0 is 0. So what I got? I got that dot product of first two vectors is 0. If the dot product of two vectors is 0, then what we say? We say that they are mutually perpendicular. You observe what I written, first vector, second vector. These two vectors are perpendicular. Now I proved that first vector, second vector are perpendicular. Now I'll prove that second vector, third vector are perpendicular. How to prove second vector, third vector are perpendicular? Very simple. Calculate their dot product. If the answer is 0, then we say that those vectors are perpendicular. You observe here, I consider second vector, third vector. Now I'll do their dot product. If the answer is 0, then I can say that they are perpendicular. Okay, if you observe, these are of the form m a bar dot n b bar. What is the formula for m a bar dot n b bar? The formula is mn times of a bar dot b bar. So here what you will get, 1 by 7 into 1 by 7, that is 1 by 49 into dot product of these two vectors. What is dot product formula? a1 b1 plus a2 b2 plus a3 b3. Okay, 3 into 6 plus minus 6 into 2 plus 2 into minus 3. Okay, that equal to 1 by 49 into 3 into 6, that is 18 minus 12 minus 6. If I simplify this, what I'll get? 1 by 49 into 18 minus 18. Minus 12 minus 6 is minus 18. Na? 18 minus 18 is 0. 1 by 49 into 0 is what? It is 0. So I proved that second vector, third vector are perpendicular. Now one more thing is remaining. What is that? Third vector, first vector are perpendicular. I want you to try this problem your own. You prove that this third vector, first vector are perpendicular. How to prove? You just calculate their dot product. If their dot product is 0, then we can say that they are perpendicular. So what you can conclude? First vector, second vector are perpendicular, and second vector, third vector are perpendicular, and third vector, first vector are perpendicular. So that we can conclude that the given vectors are mutually perpendicular. This is a little lengthy problem, but it is very easy. Okay, right. Now we will move to next question. You observe the last question for this class. What they are asking? Find magnitude of A bar and magnitude of B bar. To calculate magnitude of A bar and magnitude of B bar, they given this information. They given that A bar plus B bar dot A bar minus B bar is 8 and magnitude of A bar is 8 times of magnitude of B bar. I'll write the given data. What they given? They given that A bar plus B bar dot A bar minus B bar. They given this is 8. Okay, and they also given this magnitude of A bar can be written as 8 times of magnitude of B bar. You learn 15 formulas. Na? In that 15 formulas, this formula is there. A bar plus B bar dot A bar minus B bar. What is the formula? The formula is magnitude of A bar whole square minus magnitude of B bar whole square equal to 8. A bar plus B bar dot A bar minus B bar can be written as magnitude of A bar square minus magnitude of B bar square. Magnitude of A bar is given as 8 times of magnitude of B bar. Na? So in place of magnitude of A bar, I will write it as 8 times of magnitude of B bar. This magnitude of A bar is there. Na? That can be written as 8 times of magnitude of B bar. Here whole square is there. Na? So you will get whole square minus magnitude of B bar whole square equal to 8. Square this, what you will get? 8 square is what? 8 square is 64. 64 times of magnitude of B bar whole square minus magnitude of B bar whole square equal to 8. Here 64 times of magnitude of B bar whole square minus magnitude of B bar whole square. Subtract these two, what you will get? 63 times of magnitude of B bar whole square is 8. From this, what is magnitude of B bar whole square? That is 8 divided by 63. From this, you can write magnitude of B bar. Apply square root on both sides. Apply square root on both sides, then you will get magnitude of B bar. What is magnitude of B bar? That is root over 8 divided by 63. Here, root 8 can be written as 2 root 2. Okay, divided by 63 is there. 9 sevens are 63. So here this can be written as 3 root 7. So you got magnitude of B bar as 2 root 2 divided by 3 root 7. What they are asking? Actually they are asking magnitude of A bar, magnitude of B bar. I got magnitude of B bar. Now I will calculate magnitude of A bar. To calculate magnitude of A bar, I will use this formula only. What is magnitude of A bar? Is 8 times of magnitude of B bar. Na? Magnitude of B bar you already got here. What is this? Magnitude of B bar we got it as 2 root 2 divided by 3 root 7. If I simplify this, what you will get? 8 2s are 16 root 2 divided by 3 root 7. So I got magnitude of A bar. So what they are asking in the question? Magnitude of A bar, magnitude of B bar. See here, this is magnitude of A bar. And you observe this magnitude of B bar we got here. Magnitude of B bar is 2 root 2 divided by 3 to 7. I hope you understand this class. See, this exercise is very easy. I am saying the same thing from the beginning of theory part of dot product. If you are good in theory part, if you are thorough in all 15 formulas what we learned related to dot product of vectors, then this exercise is nothing to you. This exercise is very easy. I hope you understand this class. If you like this video, please drop a like for this video and share this video with your friends so that they will also get benefit. In case if you are not yet subscribed to my channel, subscribe now. Thanks for watching. Take care. Bye bye. Hello everyone. I am Balaji Rao. Welcome to be our maths class. In last class, we completed first 6 problems of exercise number 10.3. In case if you not watched that video, earlier classes videos link I'll give in cards. In this class, we are going to do another 6 problems. From question number 7 to question number 12, we will complete in this class. The problems in dot product of vectors are very easy, only when you are good in formulas related to dot product of vectors. We learned total 15 formulas in this dot product of vectors. I made a separate video to learn the formulas related to dot product of vectors. That video link is also there in cards. If you are good in those 15 formulas, these exercise problems are dead easy. So please go through all those 15 formulas first. Before going to start this video, please drop a like for this video. Without much delay, let's begin the class. You observe this question number 7, what they are asking, evaluate dot product of these two vectors. Okay, what to calculate? We need to calculate dot product of these two vectors. We know that dot product is distributive over vector addition. That formula is like this. What is this formula? This formula tells you that dot product is distributive over vector addition. A bar dot B bar plus C bar can be written as A bar dot B bar plus A bar dot C bar. I'll use this formula to simplify this. If I explain by this method, you may confuse. So simple thing is, you just do like a normal multiplication, but actually it is not normal multiplication. We are doing dot product of these two vectors. Multiply like a normal multiplication. Take first this vector, multiply with both the terms of this vector. What you will get, this is 3A bar dot 2A bar plus 3A bar dot 7B bar. Okay, you take this term and multiply with both the terms of this. Then what you will get? You will get like this. Minus of plus is minus 5B bar dot 2A bar. Minus of plus is minus 5B bar dot 7B bar. Just like a normal multiplication, but actually it is not normal multiplication. We applied this formula. 3A bar dot 2A bar. You learned this formula from those 15 formulas. MA bar dot NB bar. This can be written as Mn times of A bar dot B bar. Right? So what this will be? 3 into 2. That is 6 times of A bar dot A bar. Okay. Plus here what this can be written as per this formula, this can be written as 3 into 7. That is 21 times of A bar dot B bar. Okay. Minus 5 into 2, 10 times of B bar dot A bar minus 7 5s are 35. 35 times of B bar dot B bar. I hope you are understanding. Okay, this equal to 6 times of A bar dot A bar formula is magnitude of A bar whole square. You learned 15 formulas, na? In those 15 formulas, this formula is there. A bar dot A bar is magnitude of A bar whole square. Okay, plus 21 times of A bar dot B bar minus, you observe here, we know this formula, B bar dot A bar can be written as A bar dot B bar. So this is 10 times of A bar dot B bar minus 35 times of B bar dot B bar formula is what? B bar dot B bar is modulus of B bar whole square. So this is magnitude of B bar whole square. Okay, if I simplify this, what I'll get? I'll get like this. 6 times of modulus of A bar whole square plus, here this is A bar dot B bar, this is also A bar dot B bar. 21 minus 10, that is 11. So plus 11 times of A bar dot B bar minus 35 times of modulus of B bar whole square. So as they are asking to evaluate this product, so the dot product of these two vectors is this. I hope you understand this solution. You observe this question number 8. What they are asking? Find the magnitudes of two vectors A bar and B bar. Find the magnitudes of the vectors A bar and B bar means we need to calculate magnitude of A bar as well as magnitude of B bar. We need to calculate magnitudes of these two vectors. For that, what information they given? These two vectors are having same magnitude. I'll write the given information also. What they given? They given that they are having same magnitude. That means magnitude of A bar is same as magnitude of B bar. This information they given. And angle between them is 60 degrees. If I suppose theta is the angle between them, they given theta is 60 degrees. We know that dot product is also known as scalar product. That means what they given? They given that a bar dot b bar is 1 by 2. They given this information, magnitude of a bar equal to magnitude of b bar. They given angle between them is 60 degrees and they given that their dot product is 1 by 2. We need to calculate magnitude of a bar as well as magnitude of b bar. You know this formula. This is the formula we got from the definition of dot product of vectors. A bar dot b bar can be written as magnitude of a bar into magnitude of b bar into cos theta. Okay, here to calculate magnitude of a bar, magnitude of b bar, I will substitute the given information in this. A bar dot b bar, they given it as 1 by 2. Okay, right. Magnitude of a bar, I will write as it is. Magnitude of b bar is same as magnitude of a bar. So in place of magnitude of b bar, I will write magnitude of a bar into cos theta. Theta means 60 degrees here. Okay, I written like this. Now 1 by 2 equal to magnitude of a bar into magnitude of a bar is what? Magnitude of a bar whole square into cos 60 degrees. What is the value of cos 60 degrees? We know in trigonometry cos 60 degrees value is 1 by 2. This 1 by 2 will get cancelled. So what you got here? You got that 1 equal to magnitude of a bar whole square. So from this, what is magnitude of a bar? Magnitude of a bar is plus or minus 1. But we won't consider minus 1 here. Why? Magnitude means it's a length of the vector. It is always positive. So we will take magnitude of a bar as plus 1 only. So magnitude of a bar is plus 1. What is magnitude of b bar? You see in the question only they given magnitude of a bar is same as magnitude of b bar. As you got magnitude of a bar is 1, magnitude of b bar also same, because we know that in the question they given magnitude of a bar is same as magnitude of b bar. So magnitude of a bar value is 1, magnitude of b bar value also 1. I hope you understand this problem. Now we will move to next problem. You observe this question number 9. What they are asking? Find magnitude of x bar. In the beginning only they given what is to be calculated. Magnitude of x bar. If for a unit vector a bar, see here, for a unit vector a bar, that means this statement tells you that a bar is a unit vector. If a bar is a unit vector, what you know? You know that its magnitude is 1. And they given this data also. What is this? X bar minus a bar dot x bar plus a bar is 12. They given this data and they given modulus of a bar is 1. We need to calculate magnitude of x bar. See, we learned this formula from 15 formulas. A bar plus b bar dot a bar minus b bar is magnitude of a bar square minus magnitude of b bar square. You can apply this formula to this. Then what this will become? This will become magnitude of x bar whole square minus magnitude of a bar whole square equal to 12. Here you know magnitude of a bar. See, they given in the question only magnitude of a bar is 1. So I'll write that magnitude of x bar whole square, magnitude of a bar is 1. 1 square is what? 1 square is 1 only. That equal to 12. So from this magnitude of x bar whole square is what? You take minus 1 to this side. 12 plus 1 is what? 12 plus 1 is 13. Here you got magnitude of x bar whole square as 13. From this, what is magnitude of x bar? You apply square root to this on both sides. Okay, so what you will get? This side magnitude of x equal to, by mistake there is a chance you may write plus or minus root 13. But this is magnitude of a vector. Magnitude of a vector means length of a vector, that is always positive. So modulus of x bar whole square is 13. From this modulus of x bar is root 13. Magnitude of x bar is root 13. What they are asking in the question? They are asking magnitude of x bar only. We got magnitude of x bar is root 13. These are very easy problems. Only the thing is you need to throw with all the formulas. You observe this question number 10. What they given? A bar, b bar, c bar. 3 vectors given. Or 3 vectors such that a bar plus lambda b bar is perpendicular to c bar. They are saying that the vector a bar plus lambda b bar is perpendicular to c bar. Then find the value of lambda. Okay, first I'll write the given vectors. You observe, I taken given vectors a bar, b bar, c bar. Now I'll calculate the vector a bar plus lambda b bar. So first here I'll calculate lambda b bar. As lambda is scalar, what is lambda b bar? You multiply each element of this vector with the lambda. Okay, what you will get? This is minus lambda I cap plus 2 lambda j cap plus lambda k cap. What is this? This is lambda b bar. what you need? You need a bar plus lambda b bar. Okay, I'll write a bar plus lambda b bar. Okay, you observe this is a bar, this is lambda b bar. Na? When we add these two things, you can take I cap common. Then what you will get? You will get 2 minus lambda into I cap plus, you observe here, 2 plus 2 lambda, 2 plus 2 lambda into j cap plus, you observe these two, you add these two, what you will get? 3 plus lambda into k cap. When you add these two vectors, you will get like this. Okay. Now, in the question only they given that a bar plus lambda b bar is perpendicular to c bar. As they given a bar plus lambda b bar c bar are perpendicular, what you know? You know that their dot product is 0. So, a bar plus lambda b bar dot c bar equal to 0. Dot product of a bar plus lambda b bar comma c bar. What is the formula? a1 b1 plus a2 b2 plus a3 b3. That means what you will get here? 2 minus lambda into 3. 2 minus lambda into 3 plus 2 plus 2 lambda into 1 plus 3 plus lambda. Here k cap coefficient is 3 plus lambda. Here k cap term is not there. So what you will write? 3 plus lambda into 0 equal to 0. What I want to find? You see the question what they are asking? Find the value of lambda. I need to calculate lambda. You see here, if I simplify this, I will get the value of lambda. Multiply with 3, what you will get? 3 2s are 6 minus lambda into 3 is 3 lambda plus 2 plus 2 lambda into 1 is 2 plus 2 lambda only. Plus you observe this whole term 3 plus lambda into 0 is 0. So equal to 0. See here minus 3 lambda plus 2 lambda, that is minus lambda plus 6 plus 2 is 8 equal to 0. From this we can write lambda. You take minus lambda to that side, what you will get? Lambda equal to 8. What they are asking in the question? They are asking to find the value of lambda. We got that lambda value is 8. Easy problem, right? Now we will move to next question. You observe this question number 11. What they are asking? Show that this is one vector. This vector is perpendicular to this vector. Here they mentioned in the question a bar comma b bar are two non-zero vectors. We need to prove that this vector are perpendicular. To prove two vectors are perpendicular, what formula we have? We will prove that their dot product is 0. Here to show these two vectors are perpendicular, what I will do? I will calculate their dot product. If answer is 0, then I can say that they are perpendicular to each other. You observe, I consider given two vectors and I am calculating their dot product. In dot product of vectors, you learn this formula a bar plus b bar dot a bar minus b bar. What is dot product of these two vectors? Dot product of these two vectors is magnitude of a bar whole square minus magnitude of b bar whole square. You observe here, what is this? Modulus of a bar into b bar. What vector is there? Same vector is present here. You can observe magnitude of a bar into b bar, magnitude of a bar into b bar. Okay. Now you look this, what vector is there? Same vector present here. Magnitude of b bar into a bar, magnitude of b bar into a bar. So this formula we can apply to this. This is like a bar plus b bar dot a bar minus b bar. As per this formula, what I can write? Magnitude of a bar square minus magnitude of b bar square is there. So as per this formula, this can be written as magnitude of a bar into b bar whole square minus magnitude of b bar into a bar whole square. I hope you understand this step. You know this formula. Magnitude of ma bar is what? M into magnitude of a bar. Here, this is like m. This is scalar, na? This is scalar. This is like m. This is what? This is nothing but magnitude of a bar into magnitude of b bar. Here, whole square is there, na? That whole square I'll write. I hope you are understanding. See, magnitude of m b bar is what? M into magnitude of b bar. Here whole square is there, na? That's why I written like this. Minus, this is also like magnitude of m a bar. This is m. This is scalar. Magnitude of m a bar is what? M into magnitude of a bar, na? So this can be written as magnitude of b bar into magnitude of a bar. Here whole square is there, na? That whole square I'll write here. Okay, so what this will become? This is magnitude of a bar whole square into magnitude of b bar whole square minus, simplify this, what this will become? Magnitude of b bar whole square into magnitude of a bar whole square. Both are scalars. So this can be written as magnitude of a bar square into magnitude of b bar square. You observe this. This expression is same as this. Both are having opposite sign. So they will get cancelled. You will get 0. So what happened? When I calculate dot product of given two vectors, I got answer 0. So what is the conclusion? I can say that given vectors are perpendicular. So the given two vectors are perpendicular. I hope you understand this. Now we'll move to next question. You observe this is the last question for this class. If a bar dot a bar is 0 and a bar dot b bar is 0, these two information they given in the question. What they are asking, then what can you conclude about the vector b bar? You observe this is the given information. They given that a bar dot a bar is 0 and a bar dot b bar is 0. We know the formula. What is the formula for a bar dot a bar? The formula for a bar dot a bar is magnitude of a bar whole square. Magnitude of a bar whole square is 0. From this, what is magnitude of a bar? You apply square root on both sides. What you will get? Magnitude of a bar is 0. This tells you that a bar is a 0 vector. Here I came to know that a bar is a 0 vector. Now this information also given. A bar dot b bar is 0. So what is the formula for a bar dot b bar? Magnitude of a bar into magnitude of b bar into cos theta equal to 0. Here, as I know magnitude of a bar is 0, when I write magnitude of a bar as 0, whatever the things we will get here, this full product will be 0. This total product will be 0. As I got magnitude of a bar is 0, in place of magnitude of a bar if I write 0, whatever the vector b bar, this total expression will become 0 now. So here, what they are asking, what can you conclude about the vector b bar? What we will conclude? You take b bar as any vector. You take b bar as 0 vector or non-zero vector. Whatever the vector you want, you take b bar. As magnitude of a bar is 0, irrespective of b bar, this product will be 0. So, a bar dot a bar equal to 0 and a bar dot b bar equal to 0. These two things holds good for any vector b bar. You take b bar as any vector. For any vector b bar, both the results holds good. I hope you understand this class. Whatever the exercise problems we are doing in this, they are all very easy when you are good in all the 15 formulas that what we learn in theory part related to dot product of vectors. If you are thorough in those 15 formulas which are related to dot product of vectors, then you can do these problems very easily. I hope you understand this class. If you like this video, please drop a like for this video and share this video with your friends so that they'll also will get benefit. In case if you are not yet subscribed to my channel, subscribe now. Thanks for watching. Take care. Bye-bye. Hello everyone. I am Balaji Rao. Welcome to BR Max class. In last class, we completed 12 problems from exercise number 10.3 in vector algebra chapter. In case if you not watched earlier classes in this vector algebra chapter, I'll give that playlist link in cards. In this class, we are going to do from question number 13 to question number 18. Total 18 problems are there in this exercise. So in this class, we are going to complete this exercise problems. These problems are very easy when you are good in those 15 formulas what we learn in dot product of vectors. I made a separate video to learn the formulas in dot product of vectors. That video link is also given in cards. Before going to start this video, please drop a like for this video. Without much delay, let's begin the class. You observe this question number 13. If A bar, B bar, C bar are unit vectors, important information. Unit vectors means their magnitude is 1 such that A bar plus B bar plus C bar equal to 0 bar. That means they are saying that A bar plus B bar plus C bar is a 0 vector. Find the value of A bar dot B bar plus B bar dot C bar plus C bar dot A bar. They are asking to calculate this value. You observe the question, they given A bar, B bar, C bar are unit vectors. Now that means what I can write? I can write that magnitude of A bar, magnitude of B bar, magnitude of C bar. Their magnitude equal to 1. And one more information is given. What is that? A bar plus B bar plus C bar is a 0 vector. A bar plus B bar plus C bar is 0 vector means what is magnitude of A bar plus B bar plus C bar? As A bar plus B bar plus C bar is 0 vector, its magnitude is what? Its magnitude is 0. Okay. Now what I'll do, I'll square this on both sides. If I square this on both sides, modulus of this vector whole square equal to 0 square is 0 only. Why I squared? Because you learned 15 formulas, na? In that this formula is there. What is the formula for magnitude of A bar plus B bar plus C bar whole square? The formula is, this is the formula for modulus of A bar plus B bar plus C bar whole square. This formula we learn in those 15 formulas. Magnitude of A bar whole square plus magnitude of B bar whole square plus magnitude of C bar whole square plus 2 times of A bar dot B bar plus B bar dot C bar plus C bar dot A bar equal to 0. Okay, as they given magnitude of A bar is 1, magnitude of B bar is 1, magnitude of C bar is 1, I will substitute the values here. Magnitude of A bar is 1, so this will become 1 square plus 1 square plus 1 square plus 2 times of, this is as it is, A bar dot B bar plus B bar dot C bar plus C bar dot A bar equal to 0. Now 1 square is 1, 1 square is 1, 1 square is 1, 1 plus 1 is 3. I'll take this 3 to the right hand side, then it will become minus 3. See what I got, 2 times of A bar dot B bar plus B bar dot C bar plus C bar dot A bar is minus 3. Actually I am not simplifying this because this is what I want to calculate. Now what I'll do, I'll take this 2 to the other side, then what you will get? If I take this 2 to the right hand side, then what I'll get? A bar dot B bar plus B bar dot C bar plus C bar dot A bar is minus 3 divided by 2. Take this 2 to this side, you will get minus 3 divided by 2. I hope you understand this. Now we will move to next question. You observe this question number 14. They given a statement. Either vector A bar equal to 0 bar or B bar equal to 0 bar, then A bar dot B bar is 0. This is 100% true. What the statement they given, that is 100% true. If any one of the vector, either A bar or B bar is 0 vector, then A bar dot B bar is 0. But they are not asking to prove this. What they are asking? But the converse is need not be true. Converse is need not be true. You learn about converse in class 11. P implies Q. P implies Q is the statement, then its converse is Q implies P. This is little tricky one, but actually it is very easy. What I'll do, they are asking to justify my answer with an example. Na? First point, converse is need not be true. It is not compulsory that whenever A bar dot B bar is 0, any one of these two vectors is 0 bar. It is not compulsory. To explain this, I'll give an example. I'll consider two vectors A bar, B bar such that their dot product is 0. You observe here, let. That means I am considering A bar as I cap. You know I cap is a unit vector along the direction of x axis. B bar as j cap. J cap is a unit vector along the direction of y axis. I'll calculate A bar dot B bar. Here A bar is I cap dot B bar is j cap. You learn those formulas. Now in that I cap dot j cap is 0. Why? Because these two vectors are perpendicular. So their dot product is 0. Here the point is A bar dot B bar is 0. Now I'll check that either any one of the vector is 0 bar or not. As you take an A bar as I cap, what is the magnitude of A bar? Magnitude of A bar is nothing but magnitude of I cap. That is nothing but magnitude of I cap is 1 because I cap is a unit vector. Similarly, what is magnitude of j cap? Is j cap is unit vector, its magnitude is 1. Whenever A bar dot B bar is 0, it is not compulsory that either one of them is 0 vector. You see, none of the vectors are 0 vectors. Here I got magnitude of A bar is 1. It tells you that A bar is not a 0 vector. A bar is non-zero vector. Here magnitude of B bar is 1. This also tells that B bar is a non-zero vector. It is not compulsory that any one of them is 0. So whenever A bar dot B bar is 0, it is not compulsory that any one of them is 0. What this example tells? This example tells that the converse of this statement is need not be true. Whenever A bar dot B bar is 0, it is not compulsory that any one of the vector is 0 bar. Now we will move to next question. You observe this question number 15. What they given? Three vertices of a triangle ABC given. A, B, C. Three vertices respectively. Okay. Then what they are asking? Find angle ABC. That means we need to find angle B. First, I'll write the given information. This is vertex A. I written A. You know that every point can be expressed in terms of its position vector. As they given the point A, you can write OA bar. This we learn in first exercise. As they given point A, you can write OA bar. What is OA bar? OA bar is I cap plus 2j cap plus 3k cap. So when they given point A, you can write OA bar like this. This is point B. As they given point B, I can write OB bar. OB bar is minus I cap plus 0j cap plus 0k cap. This is point C. As they given point C, I can write OC bar. As they given point C, we can write OC bar like this. Okay. In the question, what they are asking? They are asking angle B. You observe, this is angle B. We need to calculate this angle. In earlier classes, we learned about angle between the vectors. This angle is angle between the vectors BA bar. By mistake also, you don't take AB bar. It is BA bar, angle between BA bar comma BC bar. This angle B is the angle between the vectors BA bar comma BC bar. This is the main point you need to know. As you know the formula for cos theta. What is cos theta formula? This is the formula what you learn to calculate angle between the vectors. Here, what is cos B? Cos B is BA bar dot BC bar divided by magnitude of BA bar into magnitude of BC bar. To calculate this angle B, this formula I am going to use. To apply this formula, I need the vectors BA bar, BC bar, but in the question they are not given BA bar, BC bar. As we know OA bar, OB bar, OC bar, we can easily calculate BA bar, BC bar. We know how to calculate BA bar. What is BA bar? BA bar can be written as OA bar minus OB bar. OA bar minus OB bar. See, this is OA bar, this is OB bar. OA bar minus OB bar. Subtract. Okay. So instead of taking scalar components here, I'll consider scalar components here. Okay. 1 minus of minus 1, that is 2. 2 I cap plus, I am just subtracting these two things. 2 minus 0, that is 2 into j cap plus 3 minus 0, that is 3 into k cap. I got BA bar. I got BA bar. As I need magnitude of BA bar, here only I will calculate this vector magnitude. See here, this vector is what? This is BA bar. What is magnitude of BA bar? Magnitude of BA bar is square root of, see here, 2 square. 2 square is 4 plus 2 square is 4 plus 3 square is 9. 9 plus 4 is 13. 13 plus 4 is 17. This is root 17. Okay. So I calculated BA bar and its magnitude. Now I need BC bar also. BC bar and its magnitude I will calculate now. BC bar. You know that BC bar can be written as OC bar minus OB bar. Okay. OC bar. This is OC bar. This is OB bar. Subtract these two vectors. Here 0 minus of minus 1, that is plus 1. 1 into I cap plus 1 minus 0, that is 1 into j cap plus 2 minus 0, that is 2 into k cap. What is this? This is BC bar. I'll calculate its magnitude. Magnitude of BC bar. What is magnitude of BC bar? Root over. Yes, here 1 is there, no? 1 square. 1 square is 1 only. Here 1 is there. 1 square is 1. Plus 2 square is 4. This is root 6. What I need? I need this angle B. To calculate this angle B, this is the formula. Okay. You observe this formula. In this, I need BA bar dot BC bar. So I'll calculate BA bar dot BC bar. Dot product of these two vectors. Dot product of these two vectors. You know the formula. A1 B1 plus A2 B2 plus A3 B3. So 2 into 1 plus 2 into 1 plus 3 into 2. A1 B1 plus A2 B2 plus A3 B3. If we simplify this, 2 plus 2, 4. 4 plus 6, 10. You got that BA bar dot BC bar as 10. What I want to calculate this angle B. To calculate angle B, this is the formula. Cos B formula is BA bar dot BC bar divided by magnitude of BA bar into magnitude of BC bar. What is this BA bar dot BC bar? We got this as 10 divided by magnitude of BA bar is what? Magnitude of BA bar is root 17 into magnitude of BC bar is root 6. Now, if I simplify this, what I will get? I will get 10 divided by root over 17 into 6, that is 102. I got that cos b equal to 10 divided by square root of 102. Actually what I need b. As cos b is 10 divided by square root of 102, from this I can write b. b is cos inverse of 10 divided by square root of 102. This angle b is nothing but the angle b in a triangle ABC. So I got that the angle b is cos inverse of 10 divided by square root of 102. I hope you understand this. Show that the points ABC are collinear. Collinear points means what? 3 or more points are said to be collinear if they lie on a same line. You know about collinear vectors. What are collinear vectors? Vectors which lie on a same line or on parallel lines are called collinear vectors. To prove these 3 points are collinear, I will prove that the vectors AB bar, AC bar are collinear vectors. If AB bar, AC bar are collinear vectors, that means AB bar, AC bar lie on a same line, then I can say that given points ABC are collinear. As they given the point A, we know that every point can be expressed in terms of its position vector. As they given point A, I can write OA bar. As they given point B, I can write OB bar like this. As they given point C as 3, 10, minus 1, I can write OC bar as 3i cap plus 10j cap minus k cap. We already know these things. Now I will calculate AB bar, AC bar. How to calculate AB bar? What is the formula for AB bar? This AB bar can be written as OB bar minus OA bar. Okay, OB bar minus OA bar. That means this vector minus this vector. See here, 2 minus 1, that is 1. 1 into I cap plus 6 minus 2, that is 4. 4 into j cap plus 3 minus 7, that is minus 4 into k cap. This is the vector AB bar. Now I will calculate AC bar. What is the formula for AC bar? AC bar can be written as OC bar minus OA bar. OC bar, this is OC bar. OC bar minus OA bar. That means this vector minus this vector. What you will get? 3 minus 1, that is 2 into I cap plus 10 minus 2, that is 8 into j cap minus 1 minus 7, that is minus 8 into k cap. You observe, I got AB bar, AC bar. What I am trying to prove? I am trying to prove that AB bar, AC bar are collinear vectors. When we say two vectors are collinear, if one vector is expressed as scalar multiple of another vector, then we say that those two vectors are collinear. You observe this AC bar. Here I can take 2 common. Take 2 common in this. What you will get? Take 2 common. What you will get? You will get I cap plus 4j cap minus 4k cap. You observe, what is this vector? I cap. 1 into I is I only now. I cap plus 4j cap minus 4k cap. So what happened? This is, what is this actually? This is AC bar. AC bar is 2 times of, what is this? This is nothing but AB bar. What happened here? I got one vector as scalar multiple of another vector. From this, what I can say? I can say the vectors AB bar, AC bar are collinear vectors. As AB bar, AC bar are collinear vectors, that means they lie on a same line. From this, I can say that the points ABC are collinear. The points A, B, C are collinear. I hope you understand this problem. Now we will move to next problem. You observe this question number 17. What they are saying? Show that the vectors, 3 vectors given. These 3 vectors forms the vertices. This is important. Vertices of a right angle triangle. What they are asking in the question? These 3 vectors forms the vertices of a right angle triangle. That means these are the vertices with their position vectors. These are not the sides of a triangle. These are the vertices of a triangle. They given in terms of their position vectors. That means if I consider ABC are the vertices of a triangle, they given OA bar, OB bar, OC bar. First I will consider given vertices with their position vectors as OA bar, OB bar, OC bar. Given OA bar, OB bar, OC bar. When we say 3 vertices with position vectors forms a right angle triangle, when I consider the sides of a triangle, if it satisfies the Pythagoras theorem, square of hypotenuse is sum of squares of other 2 sides, then I can say that the given vertices forms a right angle triangle. To get the lengths AB, BC, CA, I will calculate AB bar, BC bar, CA bar first. AB bar, As they given OA bar, OB bar, OC bar, I can calculate AB bar easily. What is the formula for AB bar? The formula for AB bar is OB bar minus OA bar. See, this vector minus this vector. Subtract 1 minus 2, that is minus 1 into I cap, plus minus 3 minus of minus 1, that is plus 1. Minus 3 plus 1 is minus 2. Minus 2 into J cap, plus minus 5 minus 1, that is minus 6 into K cap. What is this? This is the vector AB bar. As I need the length AB, here only I will calculate its magnitude. What is magnitude of AB bar? Magnitude of AB bar is nothing but AB. How to calculate magnitude of AB bar? Root over, see here, minus 1 whole square. Minus 1 whole square is 1, plus minus 2 whole square, that is 4, plus minus 6 whole square, that is 36. If you simplify this, what you are getting? You are getting AB as root 41. Now I need BC. To get BC, first I will calculate BC bar. BC bar, you know BC bar can be written as OC bar minus OB bar. Okay. 3 minus 1, that is 2 into I cap, minus 4 minus of minus 3, that is minus 4 plus 3, that is minus 1 into J cap, plus minus 4 minus of minus 5, that is plus 5. Minus 4 plus 5 is plus 1 into K cap. What is this? This is the vector BC bar. I need BC na, so I will calculate magnitude of BC bar. Magnitude of BC bar is nothing but BC. How to calculate BC? Square root of 2 square is what? 4, plus minus 1 whole square, that is 1, plus 1 square is 1, that equal to root 6. What is this root 6? BC. I got this length BC as root 6. Okay. AC bar. AC bar can be written as OC bar minus OA bar. Okay. OC bar minus OA bar. Subtract 3 minus 2. That is 1 into I cap. Minus 4 minus of minus 1. That is minus 4 plus 1. That is minus 3 J cap minus 5 K cap. As I need length AC, I will calculate its magnitude. Magnitude of AC bar is AC. How you will calculate AC? Root over, yes, 1 square is 1, plus minus 3 whole square is 9, plus minus 5 whole square is 25. So this is root 35. I got length AC as root 35. Okay, now I got lengths of sides of a triangle. I got AB, BC, CA. You observe that square of any one side is sum of squares of other two sides. You observe, square this 35. You square this 6. 35 plus 6, 41. So what you identified here? You can easily identify that AB square equal to, AB square is what? AB square is 41. Is same as BC square plus CA square. So you identified that square of one side is sum of squares of other two sides. So this tells you that these vertices forms a right angle triangle. Therefore, given vectors forms a right angled triangle. I hope you understand this. Now we'll move to next problem, that is last problem of this exercise. You please observe last question of this exercise. What they are saying, A bar is a non-zero vector of a magnitude A. That means magnitude of A bar is A, and they are saying that A is not equal to 0 because it is a non-zero vector. Okay, and lambda is a non-zero scalar. Lambda is any number other than 0. That is they given in the question. Lambda A bar is unit vector when, suppose lambda A bar is a unit vector. You take lambda A bar as a unit vector. If lambda A bar is a unit vector, what about its magnitude? As this is a unit vector, its magnitude is 1. You know magnitude of MA bar formula. What is magnitude of MA bar formula? Magnitude of MA bar formula is magnitude of M into magnitude of A bar. So here magnitude of lambda A bar formula is what? Magnitude of lambda into magnitude of A bar equal to 1. Modulus of lambda into magnitude of A bar is what? They given that magnitude of A bar is A na? So in place of magnitude of A bar I can write A equal to 1. Okay, from this what is A? A equal to 1 divided by modulus of lambda. So whenever A is 1 divided by magnitude of lambda, at that time lambda A bar is a unit vector. I hope you understand this class. All the problems related to dot product in exercise number 10.3 completed. I am repeatedly saying again and again, in this dot product total 15 formulas are there. You please learn those 15 formulas first and then start practicing these problems. These are very easy problems. If you like this video, please drop a like for this video and share it with your friends. In case if you are not yet subscribed to my channel, subscribe now. Thanks for watching. Take care. Bye-bye.